Welcome to Longevity's Welding channel. I'm Tim Roble, and today I'm going to take you through the process of more of what I do for a fabricator in a fabrication shop. There are a lot of different types of welding, such as guys that work on a pipeline may use a stick welder to weld things up. There's guys that do creative art. They might use several different processes for that, maybe a TIG, a MIG, or an arc. There's also like the job shop guy that might use the three different types of welders to get through his process. Primarily the welder that I use the most is the Longevity 200DX TIG machine. It's a full feature machine and it works really good for several different types of jobs and applications. On today's application I'm going to take you through, we're going to be welding a 2.5 inch turbo charge tube, and its material composition is 6061 T6. And basically what I'm going to do is I worked on this bike about a year and a half ago, and Ryan Keeps was trying to set a world record, and he made 5 different attempts through 5 different years and always had some type of failure on the bike. So we got in contact, he found me and came up with, hey Tim, what can we do to get you to prep this bike and do some fabrication and some engineering and design on this bike to help make it more reliable and get it down the salt flats so he can actually set a record. He's a motor guy, and putting together a good chassis for him and just components that aren't going to fail and maintain the safety of the bike and still stay within the class rules. So that's what we did. Being that this is an aluminum charge tube, 6061 T6, but it is going to sustain temperatures over 150 degrees. The proper rod through research would be the 4043 welding rod. 5356 once again wouldn't be suitable for this because it does sustain temperatures over 150 degrees. So that's what we're going to work on. Let me show you the bike. Here's a quick view of the right side of the bike. You see the race number is 1973. It does run in the A-BF 1000 class. And what this is, it's a neck-down Hayabusa motor. He's a Hayabusa engine builder, so instead of running against his clients, he's running a neck-down. So it's a 1000cc class, and it is considered a naked bike. Taking a look at the left side of the bike, all this paneling right here I did for all the tracking and telemetry, place for the computer on the bike. And then I integrated a water box that runs through the intercooler to cool everything down, but it cannot be an aerodynamic feature, so it had to be housed in the subframe. Another thing that I worked on this bike is all of the plenum, the charge tubes coming through here. I wanted to keep everything very tight and slick as I could in the wind, aerodynamic, yet trying to make it as easy as possible to work on. We actually took this charge tube and welded it directly to the turbo housing. And that's what the bike's in for right now, is we're trying to make this a little bit easier to work on in the pits, being now that it's a 218 mile an hour world record holder at the Bonneville Salt Flats. Bike's required to be tore down, and they have to check the CCs of the bike. So what we're doing now is we got a winning package. We're just trying to make it a little bit more easy to work on. As you can see, the charge tube is very tight in here. It's welded directly to the turbo, and the packaging on this whole process is very tight. What I plan on doing is taking in here and cutting and splicing and putting in a V-band clamp. This is also 6061 T6, and what this will do is it'll allow us to unbolt this and remove this charge tube just a little bit easier, so the plenum and everything up top can come out, and they can check the bike for CCs a lot easier. It'll probably take 30-40 minutes off the process versus trying to take the whole turbo apart, getting the 6 bolts off and not trying to ding an impeller and stuff. With the tank sitting off to the side, you can see some of the process here. This would be your plenum, and this is all hand built out of 6061 T6 aluminum. It's all packaged to fit underneath the tank. It's all V-band clamps that I installed a year and a half ago. And this right here would be your intercooler, and that's all set up through the water box, pumps water through, cools the air coming in so we get a more dense, cooler charge to the motor. And basically what I'm going to do is I'm going to remove, there's a V-band clamp down in here, and once again the packaging and all this is super tight. I mean, there's millimeters to spare, if that. There's some places that were so tight you can't even put a 3/1000 piece of paper in between it. But I'll remove this, and then we'll start working on where to cut down here and splice in the V-band clamp. This is the progress so far. I've removed the air cleaner, drained the radiator, removed the tubing out of the way, disconnected and removed the turbo housing. Then I've had to weld in an extension piece right here and then weld the V-band to it. Attention to detail is of the utmost importance. Missing one step here or doing something wrong could cost somebody their life. So as you can see here, I've cut this, and we're burred on the outside, which will clean all of this up on the disc sander, a belt sander, or a flapper disc. And then on the inside, normally this is where the attention to detail comes in. This is where some people would just miss and weld it together and call it good, because no one's going to ever know what's inside here. But it's the integrity with a good professional fabricator that you come through and you pay attention to detail, and you go through and you deburr all of this. You use a file. Now we have the inside all clean and deburred, and then I'll take a deburring tool and I'll just run it through the inside just to make sure we got everything out. And after I prep the outside of the tube, the next thing that I will do is I will run a rag through it to make sure that there's no contaminants left inside the tube before I go to weld it. Why is this important? Because we don't want stuff blowing from the turbo into our intercooler and filling up the veins in there. What I have here is some 6061 T6 tubing that I'm going to weld to what's supposed to be some 6061 T6 V-band clamp. But from my experience, it's not. It's kind of soft. So it may be a 6061, but it's definitely like a T3. It's a softer aluminum. I'm going to use the 4043 rod. My settings for the machine is I got about 80 amps dialed in on the foot pedal. For my AC balance, I'm at 40%, and my AC frequency is right at 230 hertz. Job complete. What first looked to be about a 1.5 to 2 hour job to splice in our V-band clamp to our turbocharged tube really resulted in, because of fitment issues deep within the motor, I ended up having to weld an extension on the charge tube, bringing everything out. It means all the geometry on this upper charge tube was not correct. So basically I had to cut everything apart, prep all the materials, and weld it all back together. But we got it all buttoned up, and she's good to go. He'll pick it up tonight and go back up to Washington and go right onto the dyno and see how we did. Thank you for watching Longevity's Welding Channel. I'm Tim Roble, and I'll catch you here next time.